All right, in this lesson 14.3, we're going to be looking at exercise problem number 2. In this exercise, it asks us to graph the following equation using intervals of 30 degrees when applicable. So the first thing we're going to do is we're going to write down the equation in our paper. The equation is P equals 2 plus sine of theta. Next step is to make a table of coordinates. To do so, we're going to take the independent variable, which would be theta, and going to put it on the left slot, and then take the dependent variable, which would be the p-value, and put it on the right slot. Now we're going to write down the degree interval increments, which would be 30 degrees. So we're going to start off from 0 degrees, go up to 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Now, how are we going to find the p-value? That's when our calculator is going to come in handy, because the first thing we're going to do is we're going to take our plot and write down our equation. Here, our equation would have to be 2 plus sine of theta, and then we're going to go to table set. In table set, we're going to write down 0 degrees for table start, because we want to start the table from 0 degrees. Then for table increment, we're going to put 30 degrees, because that's the interval in which we want to go up. Then we're going to click second table, and then here we're going to get a nice little table which is going to tell us all the p-values for the respective degrees. So if we copy down this table, we're going to have for 0 degrees a p-value of 2, for 30 degrees a p-value of 2.5, for 60 degrees 2.9 if we round it up, 90 degrees 3, and then we're going to go all the way down to 180, and then we're just gonna keep pressing down to get our next p-values. Then 1.1, 1.5 for 330, for 360 we're going to get 2. All right, so now we have our table. After we have our table, the next thing we're going to do is mark our polar graph with the degree intervals. So here we have the polar axis. We're going to put a 0 degree there, and then go on until we make a full circle, going up by 30 degree intervals. So here would be 180, go up by 30 degrees would be 210, going up by 30 degrees, 240, 270, 300, 330, and going back here would be 360, but that is the same as 0 degrees. Now that we have written down and marked our degree increments, we're going to mark the scale of the polar graph. The way I like to scale it to make it very visible and you know, to be able to actually see the graph is take our biggest p-value and go down from there. So if we take our biggest p-value, which is 3, and we work our way down from our outermost line, we would be able to go from 3 to 2 and to 1, like so. Now that we have marked our degrees and marked our scale, all we have to do is plot our points from the table that we have written down. All right, so starting off from 0 degrees, here we find the 0 degree line, and then we go to our p-value 2. 30 degree line, 2.5, about right here. 60 degree line, 2.9, as we see right here. 2.9, it's roughly there. 90 degree line, 3 on the outermost edge of the line. 120, 2.9, and go so on until we reach 360. 2.5, 180 would be 2, 210 would be 1.5, 240, 1.1, 271, 300, 1.1, 330, 1.5, and 360, 2, which goes all the way back towards the 0 degree. Alright, so now this is an even easier step. We just gotta connect the dots with a smooth line, like so. Alright, so the graph that we get is almost a circle. Not exactly, but it resembles a circle with a dip at the 270 degree line. Alright, so now that we have graphed and connected our points, the next step is to find the branch tangents. We're halfway there to being able to solve this whole problem. The way we find branch tangents is by having p equals 0. So if we plug that into the equation, it would be 0 equals 2 plus sine of theta. Now we can simplify this and solve for theta. The way we do that is subtract -2 on both sides, so we get -2 equals sine theta. Then we would be able to, we would do sine inverse -2, so that we move the sine to the other side. It would be sine inverse of, and then equal theta. So basically, this would be our end result for theta. However, if we plug this into our calculators, we do get an interesting answer. So sine inverse of -2, we get error. And the reason we get error is because a branch tangent, as the textbook defines, is a line tangent to a branch at the pole. Basically, branch tangents are lines that originate from the pole and then approximate the graph's limiting curves at a certain point. The reason this graph does not have a branch tangent is because our graph does not intersect the pole and does not touch the pole. Alright, so we have determined that our graph does not have a branch tangent. Alright, now next step, we gotta find symmetry. Our textbook gives us a nice little graph in which we can see how we can find each of the 3 symmetries. The 3 symmetries that we are looking for is 90-degree symmetry. We'll label this symmetry. So 90-degree symmetry, pole symmetry, and polar symmetry. 90-degree symmetry is symmetry that regards the 90-degree line. So if both are the same on both sides of the 90-degree line. Pole symmetry is basically when the graph is symmetric about the polar axis at any point of the polar axis. And a polar symmetry is basically a 90-degree symmetry. It has the same characteristics, but on the polar axis. right? So we're going to solve whether this graph has 90-degree symmetry, pole symmetry, or polar symmetry. The way we can do this is by determining symmetry by plugging in p-values and theta values. So the way we can solve for 90-degree symmetry is by using this equation that's in the second quadrant right here. So what we can do is plug negative p and negative theta to our equation. So if we plug negative p, it would be negative p equals 2 plus sine, and if we plug negative theta, it would be sine of negative theta, right? And the way we would solve this, all we have to do is simplify and try to see whether when we simplify, we get the same equation as our original equation, right? So now that we can simplify this, we do negative 2, negative p equals negative 2 plus sine of theta, because the negative theta goes over to the negative 2. All right, so what we can do here is divide by negative 1, negative 1. What this equals is p equals 2 plus sine theta, because this subtraction division, the division of negative 1, basically cancels out the negative. All right, so we can conclude that this graph is symmetric by the 90-degree line, right? So to find the pole symmetry, here if we look at the graph, we need to plug in negative p and theta. So if we plug in negative p and just positive theta into our equation, we would be getting negative p equals 2 plus sine of theta. All right, if we try to solve this, basically we would just get this same equation, because we cannot really simplify this anymore. We cannot divide by negative 1. And if we try to put in this second test, which would be plugging in p, and instead of sine theta, it would be sine 180 plus theta. If we do that as well, so p equals 2 plus sine 180 plus theta, we would still not get the same equation as p equals 2 plus sine theta. So negative p equals 2 plus sine theta is not the same as this, and p equals 2 plus sine 180 plus theta is not the same as the original equation. We can determine that it does not have pole symmetry. All right, now let's see whether it has polar symmetry by also looking at this fourth quadrant here. It tells us the way we can test for polar symmetry is by plugging in p equals 2 plus sine, plug in negative theta, we would get this equation right here, right? And so this would simplify basically to a p equals negative 2 plus sine theta, because as we mentioned before, the negative sign and the theta would come out to the negative 2, and actually it would go to the sine as well. All right, yeah, it would go to the sine as well. So basically we would get this equation. Now even with this equation, it would not give us the same equation as we originally had. And if we take the second test, which would be plugging in negative p, and instead of theta, 180 minus theta, we would get negative p equals 2 plus sine 180 minus theta. which still does not give us the same equation. So we can determine it's also not polar symmetric. All right, now symmetric to the polar axis here. We can also kind of see just by looking at the graph that both sides here are equal. They do have symmetric polar coordinates, right? They do not have symmetric pole coordinates because one side of the graph is different to the other side as well. All right, and it would not be polar because it's not symmetric to the polar axis. So this side that we have here is different to the bottom hemisphere that we have here. Okay, last step to solving this problem, this exercise, would be finding undefined values. Now, undefined values, why would we need to solve for undefined values? Well, undefined values, we need to find them because so often equations can limit polar operations and limit its graphs because of undefined values or imaginary ones. Okay, basically, undefined values can limit polar operations because those can cause graphs to be undefined or undefined because of imaginary values. Okay. The way we would find that a graph has undefined values and has limiting domains is basically by checking off these three criteria. The first criteria is that for a mathematical operation to be and to have an undefined outcome, the independent variable would be under an even index radical. Second criteria is that the dependent variable, which is the p-value here, the independent variable is the theta value. So the second criteria is that the dependent variable is raised to an even power. That leaves space for an undefined outcome. The third criteria is that a variable is in the denominator. Okay? So let's check off these three criteria and finish solving this exercise. First criteria, is our independent variable under an index radical? So are there radicals in our equation? There is not. So we can basically check off the first criteria. Second criteria, does our dependent variable have a power that is raised to like an even number? As we see, our p-value is not raised by an even power, so we can check off the second criteria. Right, first criteria is checked, second criteria is checked. Third criteria, is there a variable in our denominator? As we see in our equation, there is no variable in our denominator. And so we can also check the third criteria off. What this means is that we can conclude that our equation does not have any undefined values. All right. So in this lesson, we have covered how to graph a polar equation, how to make its table, how to make the degree increments, how to scale the graph, the polar graph, how to plot the points, how to do the simple thing of connecting the points. Then we solved how to find whether there's a branch tangent in the equation. And then we have solved for symmetry, what kind of symmetry there is, if there is not a certain symmetry, or if there is. And we have also solved whether there are any if there's any undefined values in our equation. So with that, we will conclude lesson 14.3, exercise number 2. Thank you.